So we're now 12:07 local time. Today is July 2nd, 2024, and the topic for today's lecture is building and training machine learning models. And I want to go through the outline specifically to address some changes I made or some things I added to the lecture based on some of the feedback and the questions that I received um in lecture two. So we're gonna start by reviewing what we discussed in the second lecture last week. We're gonna introduce supervised learning. We're gonna do model training and evaluation. What is model training and evaluation? We're gonna do introduction to Python, and we're gonna go through two examples that I really like, which is one in classification, which is we're gonna go through it, but it's trying to identify the type of a flower based on some uh, attributes. And then we're going to go through a regression example or like a typical machine learning example of diamond pricing based on multiple attributes. Then we're gonna go over overfitting and underfitting, what it means to do overfitting, what it means to do underfitting, when do they happen, and then finally we're gonna end with summary and Q&A. Again, as I go through this lecture, I will I'll be looking out for the Q&A, and then I will do my best to answer them as we're going. So, what did we discuss in lecture two? We focused on the importance of data quality. We spoke about the different methods that we can collect data. We also spoke about the different ways of pre-processing data. How can we handle missing values, feature engineering, normalization and standardization? When do we use them? What do they mean? How can they help us in pre-processing data? Then we talked about exploratory data analysis, which includes data visualization techniques, descriptive statistics, and then we spoke a little bit about Python library, specifically pandas. But I know one of the questions I got was, can we go through an example? And this is what I'm hoping and I'm planning to do today. Okay. So what is supervised learning? Supervised learning in very simple terms is learning from labeled data. So what do I mean? So, for example, if we have the most common example is house pricing. Usually house pricing is a function of or is dependent on location, size, age of the property. So in any country, mostly any country in the world, if you have enough house pricing information, if I give you the if I don't know the price of a new house, and I give you the location, the size, and the age of the house, you should be able to get these values. What are the two types of supervised learning? We have regression, which we just spoke of, like the example we spoke about, which is predicting continuous values. So, for example, a price is continuous value. Here, if I'm trying to predict the total cholesterol from the body mass index, cholesterol is a continuous value. It's a number. It is here. It goes from 140 to 280. Pricing can go from, I don't know, 20 to 20 million, depending on the currency and the location. Classification is categorical values. And the good example that actually, this is the third time I use, is this is a categorical or a classification example where you're not predicting a specific value, a specific number. You're predicting um, the animals. So this is an animal here is the category. So you have cat, frog, and dog. These are different categories. Common algorithms for both regression and classification are linear regression, logistic regression, decision tree, support vector machines. And as I said here, predicting house prices is a very good example of regression, and email spam detection is a very good example of classification. So whenever you have an email, you are usually sent a lot of emails that you don't see because they are identified by your email provider as spam. As a result, they are sent directly to the spam folder. And even now, even at this day and age with all the technology, these classifiers can sometimes still not perform as we would hope. And the good example or the very simple example that I can think of is sometimes we get very important emails that we do not receive because our email thought they were spam and they were sent to spam. And this is why I always every once in a while I check my spam to make sure that I did not get any important emails that are relevant. So let's move on. So model training and evaluation. What does it mean to train a model? What does it mean to evaluate the model? Training a model is, as the name implies, you are you are preparing the model with the correct values so that it can do a good job predicting whatever you're trying to predict. And this usually happens through splitting data into training and testing sets. Other practices when it comes to more complicated models, you can be splitting data into training, testing, and validation. But depending on the data size, depending on what you're trying to do, you don't always do that. Um, and then you use training data to fit the model. So once you split the data into training and testing, and again, I will show you the example. So hopefully this will shed some light on what I mean with these specific splitting the data and so on. Then evaluating the model. There are, because of the nature of how regression or classification happens, the way we measure or evaluate the model is very different. With regression, you use mean square error or root mean square error, and there are really others, but these are one of the most common ones. For classification, there is accuracy, there is precision, there is recall, there is F1 score, and there is ROC-AUC. These are the most common ways. Again, for the classification, these relate to how well the model is defining the class. For example, in the previous slide, the dog, the frog, and the cat. And this is, I would say, a simple guide that I saw that made sense to me on how we do the model selection process. So we define the problem, we do candidate selection, and then we do model comparison. We do performance evaluation, and then we do hypertuning. Hypertuning is changing the variables of the models to better fit the data. And then training and evaluation, and with that we do the final model selection. So introduction to Python. So I thought today, as we go through the different examples, I wanted to introduce you to some of the fundamentals and some of the basics and some of the most common libraries in Python. So Python is programming language. It's an open source, means it's for free. And there are a lot, all the libraries that you see in Python were developed by individuals, like different individuals who were passionate about this tool, who wanted to benefit more from it, and they developed these specific functionalities or specific libraries. The the six that are on the page are very relevant to really mostly all applications. The one that I would say is um, specific to machine learning is this scikit-learn. And so let me go through the six libraries, and I will discuss what each of them, what is the benefit of each of them. And I think there's this picture that I found online. I think this is a typo. It's supposed to be SCIKIT learn, not ET. So this is I may need to change this. I found this image and I realized that now that it's typo. So let's start with pandas. Pandas is the library that works with data frames. So think of Excel sheets, CSVs. Um, the library that works best with this type of data is pandas. NumPy is similar to pandas, but it works more on arrays. So think of, instead of a full table, one list of data or one row of data. Seaborn and Matplotlib are both used for data visualization. So Seaborn, I would say, is more looks nicer sometimes, but from a functionality perspective, Matplotlib and Seaborn almost do the same thing. And then you have scikit-learn, which again I'm going to change this to I because it's a typo. Um, this is where all or a lot of the machine learning libraries exist. And again, one of the reasons why Python is popular is because it's free, it's simple, and it's readable. So I can look or read anyone's code, and I would be able to, most of the times, follow the logic. That is not very common with a lot of coding languages, especially if you don't write comments. Again, it has, as I mentioned, a rich ecosystem of libraries for data manipulation, visualization, and machine learning, and there are others outside of it. And as I said here, this is the correct spelling: scikit-learn for machine learning, matplot and seaborn for data visualization, and pandas for data manipulation. So off to our first example. Um, in this example, I'm gonna just go through this slide, but then I'm gonna open Python. So we're going to use scikit-learn. One of the first most important things is for us to import the necessary libraries. We need to import the data set. We need to split the data into training and testing. We're going to go through the classification example, and we're going to fit the model, we're going to predict, and we're going to uh, do evaluation. Because this is a classification, it's more on the accuracy and not the MSE. So I'm gonna stop sharing so that I can share the code that I prepared yesterday. Okay, so I want to make sure that you can see this. Can someone write a comment confirming that they can see my screen? Perfect. Thank you, Sophia. Okay, so here is the code, and I split it into multiple blocks. Each block is doing a few things, and I'm gonna go through this example just to give everyone context. This is a tool called Jupyter. Jupyter is for me one of my the simplest tools that I use for Python. So perfect. So thank you so much, Amir. Um, the reason why I like Jupyter is many reasons. Number one, you can run certain blocks at the code separately. So for example, you see here, this is one block, two block, three block, four block. And for me personally, as I'm writing code as well as I'm teaching, it makes it very simple to really go through the lines and explain it. Second, as I code, sometimes it helps me if I have a long code and it's bugging or there are issues, when I break it down, I can quickly identify where in the code it is breaking down. Um, I'm not gonna go through the process of installation of Jupyter. I think there's a lot of information out there that can help you. My goal is to show you the capability of the tool and answer questions as I'm going through it. So the first thing that you usually do when you're working with Python after making sure you install the correct version and you install all the libraries is import the libraries. And this is the different ways you can import libraries. Either say import Seaborn, so this is one of the libraries that we talk about, as SNS. So meaning that I'm telling Python that every time I want to call Seaborn, I'm just going to write SNS. And here, import matplotlib.pyp plot pyplot as PLT. So again, whenever I need this, I'm going to write PLT. And then from sklearn that dot model selection to train test split. So this is for training and testing. From sklearn.ensemble, import random forest classifier. This is a very nice classifier. This is the model. And then from sklearn.metrics, import accuracy score, classification report, and confusion matrix. Again, very, I would say, like easy to read. And then from sklearn.decomposition, import PCA. This is something called principal component analysis. You can think of it as the PCA as a way to visualize or to see what is the most relevant factors impacting your classification. And I have a very good visual to show what it means. So one of the questions that I'm getting, I got is what does random forest classifier do? So I'm gonna go through the example and I'll show you what it does in this example. Okay, so then I'm doing the iris dataset and I'm saying SNS dot load dataset iris. So as I said earlier, the Seaborn or all the libraries are public are for free and people have done them. Actually, some libraries are not for free. I just remembered I was trying to do something and I found that one of the libraries are not free, but it's not common. But what Seaborn does that is I think is really good is that it has some data sets that we can use, anyone can use. So here I'm importing the data, and then I wanted to show the the class here, the how the data looks like. So let's run the first part of the code. Here it is. So as we can see, the data has um, 5 columns. And this is just the first 5 rows. This is why we're seeing only the first 5 rows. So you have sepal length, you have sepal width, you have petal length, you have petal width, and you have the species. So what are we trying to do with this data set? And I'm actually I would rather show the full data set. So I'm just going to come here and I'm just going to show it, all of it. And here we can find out that it's 150 rows, 5 columns, and you see the different features, you see the different species. So what we're trying to do in this model is leverage these 4 features, the length, the width, sepal width, petal width to see if we can predict the uh, if we can predict the species. So that is the goal. That is the intention. If we can take this, can we predict the species? So the next step is splitting the data. So we're gonna say, okay, we're gonna say so there is a question. Okay. So the class is going to be uploaded, it gets uploaded automatically. Um, yeah, so first thing is we're gonna take this data, these columns as X. So the first four columns as the X, because these are the dependent or independent variables. And then we're gonna take this as the Y. So here we're saying take all the data and drop the species as X. These are the features. And Y is the species, which is this last column here. And then we're saying, hey, split the data into X and Y, training and testing. And basically, we're using the train test functionality. We're doing a 30-70 split. So which test data is 30% and the training is 70%. And then we're doing random state 42. Just to give everyone context, the reason why we are selecting this random state is because uh, every time you run Python, there is a random number because this random number helps define which part of the data is the training and which part of the data is testing. However, which means every time you're going to run the model, it's going to be slightly different. So in order to make that number consistent, we're choosing this random state. So this random state is making the selection of the data, the random selection of the data constant across the different trials. And then we see the model. So this is the random forest classifier. So to answer the question earlier, this is the classifier. This is the model that is used to take the training and testing and to take the training to develop the model to predict it. Again, you were using a random state, number of estimators. I don't want to go into the details of the model, but this is some of the details. Feel free to go over the literature. It is let's say a very high level complicated model. And then we take the model, we fit it. So we say take the training and test it and train the model. And then we are predicting. So we're taking the testing data and we're using the model that we just developed to predict the Y prediction. And then we are taking the prediction and the actual data, which is the Y test, and we are doing an accuracy. And we're printing the classification report and we're printing the confusion matrix, and you're gonna see what it means. One comment I want to say here is this model is gonna be perfect, and the reason why um perfect it is perfect is because this data is hand-picked, and this model is very powerful. So in general, if you develop a model and it has an accuracy of 100, like the one you have here, I want to say 100% of the times, or let's say 99% of the times, there is an issue with the data. But this data is set up to be very easily trainable, and this is why the performance is gonna be of 100%. So I see two questions here about the random state, and I'm gonna go over it again. So what is the meaning of 42? So really 42 can be any number, really any number. Uh, so it can be 30, it can be 1, it can be 0. I think it can be any positive number if I'm not mistaken. I need to check, but I always use like 1, 2, 3 or 42 or 50. Like it can be any number. The random state is there are in these when you're splitting the data into training and testing, there is a random element to it. You have 150 rows. 70% is of training that is 105 samples, I think. So which 105 samples are you going to take? Every time you run it, if you don't have a random state, let's actually let me show you. Let me show you right now. So I will take this part and I will show you the different ways. Okay, so here we picked a random state. So let's say we do not pick a random state. Yeah, so I'm gonna remove it and I'm going to show you the impact of not having it. So I'm gonna show you the X testing. So we run it first time. So we see this is the rows that were picked. Okay. So you see the first one is 124. If I run it again, it's gonna be different. So it took a different set of samples. If I run it again, it's gonna be different. Because every time there is this randomizer that is taking it, giving you a different number. However, if I want to make it consistent, so every time I take it, I would get the same number. So I would do just any random number. So I can do one. So here, every time I run it, it's going to give me this. See? I run it again. Same exact sample. So this way, if you're running your code today and you want someone else to validate your code or run your code to get the same results, you would pick that random state. So let's say we're going to keep it for two just because I wrote for two, but there is no value of having a one number versus the other. So 42 gives me a specific one. If I run it again, it's going to give me the same one again. So I hope this clears out what it means, the random number again. So yeah, again, I answered what would happen if you put any other number. Please do the libraries imported do the libraries imported come with the Jupyter editor or one has to download the libraries? Some do and some don't. Some you would have to install, some come with. Okay, so let's continue. So here okay, so once let's see what happens when we run this. Here it is. As I said, the accuracy is one. The precision recall is one, which is excellent. The accuracy is one. Again, this is a very because it's a very simple data set. It's showing it's doing very well, and that's why you have 100 all the way. And let's visualize this. So the confusion matrix, so it's showing that really having zeros on the side is showing how good the prediction is. Um, Here we're gonna visualize the principal component analysis, and we're gonna show some other plots. Okay, so for some reason, oh, I didn't import pandas. Here it is. So this is the principal component analysis that I've gone through. And here it's really showing two principal components. So what it does here, just to give you a very high level, the principal component takes all of these variables, or all of these features, and combines them into two features in a very it's a very complicated way, but it does a good job because now you can see why you're getting a very good model because according to the principal components, which are how the model sees the data, they are very distinct. So Setosa is very unique here. There is some overlap between the versicolor and the virginica, but it's very slight and it can be very distinct. So, for example, if some of the testing data was here, the data could have been predicted. So yeah. So this concludes the first example. So let me share my slides again to go over um, my next example, which is linear regression. In this example, we're gonna go over diamond pricing. Again, we're gonna look at features. We're gonna look at target variables. We're gonna do a similar thing, which is loading the data set, splitting the data into training and testing, building and training the model, and evaluating the model performance. So let me share my screen again. I want to make sure that you can see kernel. Can you see my? Okay, no, I don't think you see the correct page. Let me. Can you see my page now? Can you confirm seeing the lecture 3 example linear regression? Perfect. Thank you. Okay, so here we're going to do the same thing, which is importing the library, importing the data set, and I'm going to show you how the data looks like, the head of the data. So here we have the diamond carat, the cut, the color, the clarity, the depth, the table, the price, um, the XYZ, the dimensions of uh, the the diamond. And here the price is what we're interested in. So we want to know if depending on these features, what is the price. So again, the we're not even taking we're only taking the continuous variables, which is the carat, depth, table, XYZ. We're not taking the cut, color, or clarity because these are what is referred to as categorical variables. For a model to use them, you need to change them, and I thought it would be too complex for this example. So um I just took um I just took the color. I just took the continuous variables here. Here again, taking x, y, splitting them using linear regression, which is the simplest regression model. I'm fitting the model. I'm predicting the model. Again, I'm doing the R2 score to show how the model is doing. I don't think this model is as good. Yes, it is only 86%. Again, with relatively high mean square error, but 88.86 R squared is not too bad. So I want to visually show you the data so that you know what it means to get a 0.86. So here is the model. So you have the true values on the x-axis, you have the predicted values on the y-axis, and as you can see, the black line is the model. So again, all of this are um, undervalued by the model, and all of these are overvalued by the model because or yeah, actually, all of these are undervalued with the model, and all of these are overvalued by the model because if the true value is here, the model is showing that it's here. So as you can see, this is why this model is not as good as the other model, and that makes sense because the linear regression model is one of the most basic models out there. And I want to show you one good example and one not so good example. And here is the residuals. And finally, I wanted to show you how the different variables relate within this data set by plotting something which is the pair plot, and you're going to see what it is now. Yeah. So here I'm showing how the different things correlates. For example, the one that I like the most is carat and XYZ. So it makes sense that as the carat increases, as the size increases, because they are related. This is exactly what it means. When the carat of the diamond increases, the size of the diamond increases. So this is a very good way to just visualize dependency and see if variables are dependent. Usually it is not actually good to have codependent variables or dependent variables. in the training data set. So for example, if I'm actually doing this and I want to predict a model, I would remove the XYZ because it's already captured in the caret. As the caret increases, the XYZ increase. And here, the price, again, we see that as the caret increases, the price increases. That just goes without saying. Okay. Any questions? Okay. So I will share my screen again on the PowerPoint. So after we've gone over the uh, after we've gone over the classifier and the regression example, I want to go over what it means to overfit the model or underfit the model. And this is something that is very, very common as you're developing machine learning models. Uh, Overfitting usually happens when your model is usually it happens when the sample of the data is not very is not done properly. So here the the model is predicting the training data set very well, but it does not do a good job expanding beyond the training. So you see here, this is a classification example at the bottom right. In the overfitting example, it is basically going over the testing to classify it well. You find out that you overfit. The best indicator is high accuracy on training data and low accuracy on testing data. With underfitting, usually the sample size is too small that you're training, or it's not representative of the actual pattern. And this is usually provided or usually indicated by low accuracy in both training and testing. So some ways to mitigate overfitting is cross-validation, regularization, pruning for decision trees. And I would not worry too much about these. I think at this level of learning, you just make sure you take a random sample. They just make sure you take a lot of data for training, and then you should not worry about overfitting or underfitting. So someone's asking me, are we the ones supposed to write all those codes? The codes that you saw earlier, usually yes. I mean, now with ChatGPT, ChatGPT writes can help you write code, which was not the case when I was learning. But in general, yes, you would need to write your own code. Yes, that is how coding usually works. Um, I can actually that's a great question about the example code. I can put the codes within the quiz. So at the bottom of the quiz, I will add the codes. So let me keep that question so I can remember that. And if I don't do that in the quiz, remind me and I will do that in the next lecture. So what is the summary and takeaways of this lecture? Today was a more of a demo lecture. So what is the key points? Introduction to supervised learning. We went over model training and evaluation. We went through Python, classification, linear regression examples. We talked about overfitting and underfitting. I want you to come out of this lecture understanding the importance of splitting data for training and testing, familiarize with common evaluation metrics, recognize the signs of overfitting and underfitting, and how to use some libraries in sklearn for model building. So I think this concludes our lecture. So I see a few questions. Feel free to write um, the question. So I will give the code in what I mean is the quiz is going to have the questions, and then on the second page there's going to be the code so that you can look at it. This is what I meant. This way you have one document instead of multiple documents. So hopefully that is clear. I'm not going to quiz you on the code. I'm just going to have the code in in the quiz itself document. Are there any more questions? No, no, no. So no, no. So someone's asking where do they store all these training models, like the infrastructure? Are they a collection of mini computers? No. The algorithm itself is in the library, so the lines of code are how it trains the model. However, it leverages your local RAM and local memory and local processor to basically train the model. There are models that use like cloud-based, but that there are these are specific. If I wish to start learning ML, what should be the best resource? Any book. My best advice would be online courses like this one, or there is an excellent one in Coursera, Fundamentals of Machine Learning. There is also like data camp. There's a lot of tools out there where you can learn. What is the classroom code for this class? I actually don't know that answer. If anyone knows it, they can write in the question and I'll give you the answer. So this is what is the classroom code for this class? I'm not sure. Okay. Any more questions? Okay. If there are no more questions, this concludes our third lecture. So someone is asking a silly question perhaps, but do we write our own models, right? So I'm not sure I know what you mean by models here. So for example, if you say linear regression, you don't write the model. You just call it, and the code is already written. But by writing, for example, splitting data into data, test, and data, this is what I mean by writing the code. Does that answer your question? Okay, great. Thank you, everyone. Have a great rest of your day, and I'll see you next week for our last lecture. And I hope you've enjoyed it, and let me know if you have any questions um, as we conclude our class next week. Have a good day, everyone. Bye.